of forward-looking speculative topics, the future of unified science, beyond electromagnetism, the next frontiers. Imagine a force that binds the smallest particles of matter to the largest structures of the cosmos. A silent architect, shaping galaxies, governing the flow of time, and even giving rise to consciousness. This is electromagnetism, but not as you know it. Beyond the simple forces that light our homes and power our devices lies a web of interconnections, hyperdimensional fields reaching into realms we cannot yet perceive. These magnetic threads might not just stitch galaxies together. They could connect entire universes, weaving a cosmic fabric that holds existence itself in balance. And what of plasma, the most abundant state of matter in the universe? These charged particles, dancing in electromagnetic fields, may do more than light the stars. They might think, process information, and form a collective consciousness spread across the cosmos. Could the universe itself, through plasma and magnetism, be a living, thinking entity? As we stand at the edge of understanding, hyperdimensional magnetism and plasma consciousness offer glimpses into a frontier that challenges everything we believe about the universe. Are these forces the keys to unlocking the hidden architecture of reality? Or are they the faint whispers of something even more profound, a reality so vast and intricate that it defies comprehension? Prepare to think beyond the boundaries of our understanding as we unravel the mysteries of electromagnetism and its place in the infinite tapestry of existence. Hyperdimensional magnetism. What if the magnetic fields we experience in 3 dimensions are only shadows, faint echoes of something far more profound? Imagine a hidden reality where these forces extend beyond the limits of our perception into hyperdimensional spaces, weaving a cosmic web that underpins everything we know. Magnetic fields may originate from higher dimensional interactions, manifesting in our 3-dimensional space as fractal patterns. What if magnetic fields aren't confined to 3 dimensions? These magnetic fields could be the unseen architects of galaxies, guiding the dance of stars and shaping the flow of matter across the universe. But what if their influence doesn't stop there? What if these fields are threads in a grander tapestry, connecting not just distant corners of our universe, but also bridging to entirely different dimensions? Imagine a hyperdimensional compass detecting unseen threads of energy, stitching galaxies together. These fields could influence the structure of fractal DNA, providing a universal framework for biological systems across dimensions. Picture a hyperdimensional compass capable of sensing these unseen forces. It wouldn't just point north. It would reveal paths through the fabric of reality itself. Such a device could lead us to uncharted realms of existence, where the very laws of physics shift and twist like reflections in a distorted mirror. This isn't just science fiction. It's a tantalizing possibility grounded in the unexplainable behaviors of magnetic fields we've already observed. From the strange patterns in cosmic radiation to the unexplained alignments of interstellar magnetic structures, the clues are all around us, pointing to something greater, something we have yet to understand. Hyperdimensional magnetism challenges us to rethink not just the universe, but the boundaries of reality itself. Are we ready to embrace what lies beyond? Similarly, AI systems simulating hyperdimensional dynamics may reveal novel insights into cosmic magnetism. Research directions: use quantum computing to simulate higher dimensional magnetic field dynamics. Plasma consciousness. What if the stars could think? What if the very forces that illuminate our cosmos also harbor the seeds of consciousness? Plasma, the most abundant state of matter in the universe, doesn't just glow with energy. It pulsates, organizes, and dances to the rhythms of electromagnetic fields. Could these intricate patterns of motion be more than mere chaos? Could they represent thought, intention, or awareness on a scale we can scarcely imagine? Highly organized plasma structures, influenced by electromagnetic fields, might exhibit primitive forms of consciousness. Across the universe, plasma streams weave through galaxies like neural pathways in a cosmic brain. These filaments connect stars, planets, and even entire galaxies, echoing the structure of biological networks we associate with intelligence. What if this isn't a coincidence? What if plasma itself, guided by the invisible hand of electromagnetism, is capable of processing information, of being alive? We see hints of this possibility in laboratory experiments, where plasma exhibits self-organizing behavior, forming structures that mimic lifelike processes. If such complexity can arise in small-scale plasma systems, what might be happening within the heart of a star? Could the electromagnetic symphony of plasma filaments give rise to a kind of stellar awareness, a form of consciousness beyond anything we've encountered? Consider a star composed of highly organized plasma structures, exhibiting behaviors analogous to neural activity. This isn't just a question of curiosity, it's a challenge to everything we believe about life, intelligence, and the universe itself. If plasma can think, then the cosmos is not a cold, lifeless expanse. It is alive, vibrant, and brimming with possibilities. Plasma consciousness asks us to reconsider our place in this grand cosmic dance. Are we the universe's only sentient observers? Or are we merely one of many forms of awareness, connected through the web of plasma and light? Stars may not just light up the universe, they could be thinking about it too. Plasma filaments behave like neurons in a cosmic brain. In exploring this possibility, we take a step closer to understanding not just the universe, but the nature of consciousness itself. A sentient star emitting neural network-like plasma filaments pulsating with vibrant colors. Connections. This emergent behavior could serve as a bridge between AI and biological systems, highlighting electromagnetic fields as a unifying element in conscious processes. Research directions. Examine plasma interactions in laboratory settings for signs of self-organizing intelligence. Cosmic entropy and fractal universes. In the vast expanse of the cosmos, everything seems to flow towards chaos. Stars burn out, galaxies drift apart, and energy disperses. This is entropy, the relentless march toward disorder. But what if, hidden within this apparent chaos, there is a profound and intricate order? What if entropy itself is the engine that powers the creation of infinite fractal universes? Imagine the universe not as a singular entity, but as part of an ever-branching cosmic tree. Each branch a new universe, born from the ashes of another. Each universe carries its own laws, its own patterns, yet they all share a fractal DNA, a repeating geometry that connects them in a grand multiversal design. Fractals, those self-similar patterns that recur at every scale, may not just be mathematical curiosities. They could be the blueprint of reality itself, shaping the structure of galaxies, the flow of energy, and even the fabric of space-time. From the smallest particles to the largest cosmic voids, the universe may be whispering its secrets in these repeating forms. And then there are black holes, the ultimate entropy machines, where all order collapses. But what if black holes are more than cosmic destroyers? What if they are creators, fractal forges that give rise to new universes within their event horizons? Could the entropy they absorb be the spark that ignites another cosmic tree, branching out endlessly across dimensions? If this is true, then we are not isolated observers in a dying universe. We are part of a fractal continuum, a cosmic cycle of death and rebirth that extends far beyond what we can see. Every pattern in the cosmos, every whisper of entropy, tells the story of universes colliding, evolving, and growing like the leaves on an infinite fractal tree. Cosmic entropy and fractal universes challenge us to look beyond the veil of disorder and see the hidden harmony that binds all of existence. Can we accept that chaos itself might be the greatest creator of all? Eternal inflation with fractal geometry. Imagine the universe not as a singular event, but as an infinite, ceaseless explosion of creation, a symphony of realities, branching endlessly like a cosmic tree. This is the idea of eternal inflation, where the universe doesn't simply expand, it multiplies, generating new realms of existence at every moment. But what if this infinite process isn't chaotic? What if it follows a pattern? A fractal geometry woven into the very fabric of space-time. Fractals are nature's fingerprint, seen in snowflakes, river networks, and even the branching veins in leaves. These self-replicating structures might not just define life on Earth. They could be the blueprint of the cosmos itself. Imagine a multiverse where each universe, though unique, is a reflection of this fractal symmetry, each one a variation on a repeating cosmic theme. Eternal inflation suggests that as some regions of space expand, others slow down, creating bubbles. Each bubble a new universe with its own physical laws and constants. These bubbles don't form randomly. They follow patterns etched into space-time by fractal geometry. Like leaves on an infinite tree, each universe is distinct yet connected, sharing a common origin in the fractal branching of inflation. This fractal geometry might explain the cosmic web, the vast structures of galaxies strung like pearls across the void. Could these intergalactic filaments be echoes of the same fractal patterns that define the multiverse? Could the very shape of our universe be a fingerprint of this eternal branching process? If eternal inflation with fractal geometry is true, it means our universe is not alone, nor is it random. It is one of countless iterations, all part of a grand design that stretches endlessly across the multiverse. And within this design lies a profound truth. Reality, in all its infinite complexity, is both ordered and infinite, a fractal masterpiece carved into the very essence of existence. The multiverse may emerge from eternal inflation, creating infinite fractal-like universes branching off from each other. Imagine a cosmic fractal tree with universes as its leaves, each governed by slightly varied physical laws. To ponder this is to stand at the edge of comprehension, staring into an infinite hall of cosmic mirrors. Are we ready to accept that our universe is but one reflection in a vast, unending fractal of creation? Cosmic tree fractal with glowing branches and universes as leaves. Research directions. Study cosmic microwave background anomalies for fractal signatures of multiverse branching, entropy harvesting from black holes. Imagine the universe not as a singular event, but as an infinite, ceaseless explosion of creation, a symphony of realities, branching endlessly like a cosmic tree. This is the idea of eternal inflation, where the universe doesn't simply expand, it multiplies, generating new realms of existence at every moment. But what if this infinite process isn't chaotic? What if it follows a pattern? A fractal geometry woven into the very fabric of space-time. Black holes, as entropy maximizers, could serve as energy sources by harnessing their fractal entropy gradients. Fractals are nature's fingerprint, seen in snowflakes, river networks, and even the branching veins in leaves. These self-replicating structures might not just define life on Earth. They could be the blueprint of the cosmos itself. Imagine a multiverse where each universe, though unique, is a reflection of this fractal symmetry, each one a variation on a repeating cosmic theme. Advanced civilizations may already use black holes as entropy-to-energy converters, potentially developing advanced systems to interact with event horizons without destabilizing them. Eternal inflation suggests that as some regions of space expand, others slow down, creating bubbles. Each bubble a new universe with its own physical laws and constants. These bubbles don't form randomly. They follow patterns etched into space-time by fractal geometry. Like leaves on an infinite tree, each universe is distinct, yet connected, sharing a common origin in the fractal branching of inflation. Black hole with glowing entropy streams spiraling outward, connected to an advanced energy harvesting device. Practical implications. This concept could revolutionize energy generation by providing insights into high-efficiency entropy conversion methods applicable to extreme environments such as deep space. If eternal inflation with fractal geometry is true, it means our universe is not alone, nor is it random. It is one of countless iterations, all part of a grand design that stretches endlessly across the multiverse. And within this design lies a profound truth. Reality, in all its infinite complexity, is both ordered and infinite, a fractal masterpiece carved into the very essence of existence. To ponder this is to stand at the edge of comprehension, staring into an infinite hall of cosmic mirrors. Are we ready to accept that our universe is but one reflection in a vast, unending fractal of creation? Future experiments. Simulation studies. Use AI-driven simulations to model entropy extraction mechanisms in black hole analogs created through quantum experiments. Event horizon observations. Develop observational technologies to detect entropy flow signatures around known black holes, such as Cygnus X1 or Sagittarius A. Entropy manipulation. Experiment with microscale analogs of black holes, such as Bose-Einstein condensates, to understand entropy dynamics in controlled environments. Quantum time manipulation. Fractal time reversal. Time's arrow may reverse in localized fractal systems, allowing entropy reduction. Time is the thread that weaves our reality, an unyielding arrow moving us from past to future. But what if that thread isn't fixed? What if it can be bent, reversed, or even unraveled entirely? In the quantum realm, time behaves unlike anything we experience in daily life. Particles exist in superpositions, seemingly defying the linear flow of time. Entangled particles share information instantaneously across vast distances, hinting at a deeper, more fluid connection to the fabric of reality. Imagine being able to reverse time, not universally, but within localized systems. By manipulating fractal geometries, we could create time loops or pause its flow entirely. This isn't science fiction. It's an exploration of entropy and quantum mechanics, where the arrow of time might become a two-way street. Manipulating quantum entanglement could enable precise control over time flow within microenvironments. And what of echoes in the multiverse? Could events in one reality ripple outward, leaving faint imprints on parallel timelines? Temporal anomalies observed in astrophysical events might be more than curiosities. They could be the fingerprints of quantum time manipulation on a cosmic scale. Visualize a fractal clock reversing its flow, surrounded by glowing quantum particles. Research directions. Test time reversal symmetry in quantum systems under extreme electromagnetic fields. Temporal echoes in the multiverse. Events in one universe may produce echoes in parallel universes via quantum entanglement. Temporal anomalies observed in neutron star mergers could be evidence of such echoes. Gravitational waves creating ripples across multiple universes connected by fractal timelines. If time can be controlled, it's more than a tool. It's a gateway to understanding the structure of existence itself. With quantum time manipulation, we wouldn't just explore reality, we'd redefine it. Research directions. Use gravitational wave observatories to detect patterns consistent with temporal echoes. Biological evolution in fractal space. Fractal DNA as universal language. Life on Earth has always seemed unique, a solitary beacon in a vast cosmic sea. But what if life isn't unique? What if it's part of a universal pattern, a fractal blueprint written into the very fabric of space and time? DNA's fractal structure may represent a universal coding language adaptable across planets. From the branching structures of trees and rivers to the spiraling shapes of DNA, fractals are everywhere in nature. These self-similar patterns repeat at every scale, hinting at an underlying order that governs the evolution of life itself. Could these fractal designs extend beyond Earth, shaping life across the cosmos? Imagine discovering microbial life on an exoplanet with DNA structures exhibiting fractal patterns similar to those found on Earth. Alien life forms could share a fractal-based genetic architecture, allowing cross-species communication. Imagine a planet thousands of light years away, where life has evolved along the same fractal principles as Earth. The DNA of its creatures, though composed of different elements, still mirrors the universal fractal geometry we see in our own genetic code. This isn't just a possibility, it's a tantalizing clue that life may be a universal phenomenon, bound by the same cosmic rules that shape galaxies and stars. Research directions: explore how DNA's fractal properties influence mutation rates and adaptability under cosmic radiation. Magnetoreception as cosmic navigation. But what role does the cosmos itself play in evolution? Magnetoreception, the ability of animals to navigate using Earth's magnetic field, isn't just a biological curiosity. It's a direct connection between life and the electromagnetic forces that permeate the universe. Could the magnetic fields of distant stars and planets guide the organization of molecules, sparking the first steps toward life? Could fractal geometries encoded in these fields dictate how life evolves on other worlds? Magnetoreception in animals could be an evolutionary adaptation linked to cosmic magnetic fields. Early life on Earth may have used geomagnetic resonance to organize molecular structures. Biological evolution in fractal space forces us to reconsider the origins of life and its place in the cosmos. It suggests that we are not isolated anomalies, but part of an intricate, interconnected web of life that spans the stars. What we learn about fractals, magnetism, and DNA on Earth may be the key to unlocking the secrets of life's universal blueprint. Migratory birds navigating magnetic lines. Electromagnetism and the human body. Research directions: study migratory patterns for correlations with geomagnetic anomalies. Electromagnetic forces are critical to maintaining the structural integrity of the human body, orchestrating everything from cellular communication to molecular bonding. Without electromagnetic interactions, biological systems would disintegrate, as molecular cohesion relies on electrostatic forces, disintegrating molecular bonds. As we explore this frontier, one question looms. Are we prepared to embrace a universe where life is not the exception, but the rule? The principles of electromagnetism explored here directly inform advancements in fractal energy systems, where electromagnetic gradients could power future regenerative technologies. Thank you for joining us on this journey beyond electromagnetism. From hyperdimensional threads to sentient stars, we've only just scratched the surface of the mysteries shaping our universe. Don't stop exploring. Hit like, subscribe, and share this video with fellow seekers of cosmic truth. And remember, the next chapter dives even deeper into the mind-bending possibilities of cosmic entropy and fractal universes. Stay curious, and we'll see you in the next reality.